Hello, my name is Dylan Romero, and I work in the UCSF Library's Makers Lab. I'm here with you today to talk about the UCSF 3D printed face shield project. During this presentation, we'll provide an overview of the manufacturing process for the face shields. This information can be replicated at your institution if you are in need of face shields. One of the challenges UCSF hospitals and hospitals around the world are facing during the COVID-19 pandemic is a shortage of masks, face shields, and other forms of personal protective equipment, or PPE. UCSF currently needs over 300 face shields per day. 3D printing and other additive manufacturing technologies are being used to fill the gaps in the PPE supply chain. Each face shield that's being manufactured at UCSF is built from the following components. First is a shield frame that is 3D printed. Second is a shield that is made of a clear A4 transparency sheet. Third is a strap which consists of 2 to 3 interlocked rubber bands that secures the face shield to the frontline worker's head. The face shield frames can be disinfected after use and used multiple times. The shields must be replaced after each shift and should not be clean to help maintain clarity and visibility. Face shield design files and instructions for manufacturing can be accessed on the UCSF Library's Makers Lab website using the link shown on this slide. You will find two posts related to the face shield project. First is an overview, which is called the UCSF 3D printed face shield project. This provides an overview of the project and step-by-step instructions for manufacturing. Second is the UCSF 3D printed face shield repository. This is where we upload and share all of the models related to the 3D printed face shield project. Anyone from around the world can download the 3D models or STL files from the repository at no cost and begin to 3D print face shields for their own institution. The UCSF 3D printed face shield project is a collaboration between the following departments. First is UCSF Clinical Technologies. They manage the face shield project and are in charge of distribution. The manufacturing is happening inside the UCSF library, also using 3D printers and staff time from the Makers Lab. UCSF Department of Orthopedic Surgery have also loaned 3D printers for the project as well as shared expertise. UCSF Documents and Media have been very helpful drilling the clear transparency sheets that are being used for the shields. This has saved us a lot of time. They can drill a couple of thousand of face shields in an afternoon while keeping those sealed. San Francisco VA has also loaned 3D printers for the project. Human Made is a local nonprofit makerspace in San Francisco that has also been providing 3D printing services. And most importantly, volunteers from across the UCSF and Bay Area community have been lending their time to come in and help with the face shield project. Some background on the project. On Thursday, March 19th, 2020, UCSF Clinical Technologies reached out to the Makers Lab to request 3D printed face shields for UCSF and Bay Area hospitals. After creating a model, a workflow, and receiving approval from multiple UCSF departments, over 300 face shields are being manufactured in the UCSF library every day. Each face shield costs under $1 to make and can be delivered to the hospital the same day. Next, I would like to go through the production process for the face shield project. It consists of the following 6 steps: 3D design, 3D print, cleanup and quality assurance, disinfect, assemble, and finally package. Before we talk about production, I want to make a couple of comments about safety. First, coronavirus COVID-19 can live on the plastic and various surfaces for 48 to 90 hours, and plastics cannot be easily sterilized after use. You're going to want to work closely with infection control and hospital to approve design and production, and including any cleaning policies for your space. Ensure there is proper ventilation in each of the 3D printing manufacturing rooms. All volunteers must undergo a screening process before each shift. And last, PPE must be worn while working, which includes bunny suits, surgical masks, bonnets, and gloves. The first step in the production process is 3D design. The UCSF face shield is based off of the Prusa face shield model, which is also available online at no cost. The UCSF model is optimized to 3D print faster and has been customized based off of clinician feedback. The model was designed in Autodesk Fusion 360, and 3 models are currently available. A Model A, which is the standard size that you see here, Model B, which is a smaller size that will fit on smaller 3D printers, and Model C, which is the standard model but with an addition of a protective visor. Models are stacked to minimize downtime and to allow us to 3D print overnight. You'll see a picture of that in just a moment. The second step of the production process is 3D printing. We have over 20 3D printers in the UCSF library that are in operation from 8 a.m. to 8 p.m., and some print overnight. We are currently using a combination of the Lowellspot TAS6 and Prusa i3 MK3S 3D printers for this project. That is due to their size and reliability, but other printers can be used as well. PETG is a preferred filament due to its flexibility, chemical resistant qualities, and also because it can be recycled after use. Frames typically take 40 to 90 minutes to 3D print depending on the 3D printer. What you see here in this photo is a Model A that is being printed in a stacked format. So that allows us to print 16 shields in one print that takes roughly 10 hours. So that's been a much more efficient approach for this project, allowing us to start a print before we leave for the evening, allowing it to run overnight, and then we can continue with a second print when we get in the morning. Step 3, cleanup and quality assurance. The following steps are taken to clean up the face shield after being removed from the 3D printer. First, inspect frames for failures. If any failures are found, remove from production immediately. Second, using a rotary tool, remove any large burrs from the 3D printing process. Third, using a small sanding block, smooth out the inside of the frame that touches the forehead of the clinician. This makes the frame more comfortable to wear and allows clinicians to wear it for a longer period of time. Step 4 is disinfect. So after the cleanup process, spray each frame around 3 times using a 70% alcohol solution to disinfect. If the frame was 3D printed outside of the library, we take the additional step to wipe down the frame with Clorox wipes. Allow the frame to dry for at least 30 minutes. Next step is assemble. After the frames have dried, interlock 2 to 3 rubber bands and connect rubber bands to the hooks on the side of face shields. The final step of production is packaging. Place 50 frames in a bag and place 2 bags in each tote. Each tote will have 100 frames. We place 2 packs of 100 transparency sheets in each tote. Those transparency sheets are pre-drilled off-site. The transparency sheets are connected to the face shields at the hospital. This allows for better transportation and minimizes exposure. We close the tote and seal with tape, writing quantity, date, and time before sending to the hospital. We hope this information is helpful if you are interested in manufacturing face shields at your institution. The following resources are also available to help you get started. First, you can visit the UCSF Library's Makers Lab website for more information about the process and to access 3D models. You can email 3D face shields at ucsf.edu with questions. You can also follow UCSF 3D Shield on social media. Thank you so much for joining me today. Be well and let us know if we can help.